Welcome back to the Otter Share. I'm glad you could join me here on the riverbank. Down there on the sun-warmed rock is Sedge. He is sorting his morning catch, carefully lining up these long, thin strips of fish side by side. Notice how each strip he lays out is precisely the same length as the next. That alignment is deliberate. To figure out the true size of any piece of a whole, we have to start with holes that match exactly. Without that matching foundation, a fair comparison simply will not work. Let's watch him work. Sedge takes the top strip of his catch and separates it into two perfectly equal sections. We call these halves. Then he takes the second strip, the one matching the first, and divides it into 4 equal smaller pieces. These are fourths. He pushes one of his halves directly against 2 of the fourths to see how they line up. The outside edges meet perfectly. Because they cover the exact same distance along the rock, 1/2 is exactly equal to 2/4. Sedge made a different number of cuts, but the total amount of fish reaches the exact same place. That means the fractions themselves are mathematically equal. Sedge brings up 2 fresh strips from the river for a new trial, and once more he makes sure they are identical in length. He divides the top strip into 3 equal pieces, sliding one section, 1/3, forward. He then divides the bottom strip into 6 equal pieces, sliding 2 of those sections, 2/6, forward to join it. He stacks the 1/3 section right alongside the 2/6 section, and again, the outside edges align flush with each other. Because the lengths match exactly, we know that 1/3 equals 2/6. 2 smaller pieces can reach exactly as far as one larger piece, provided they are cut from holes that are the same size to begin with. Now we can see what happens when the lengths do not match. Sedge sets 1/2 strip down and puts 1/4 strip right next to it, pulling both from identical holes. Looking closely at the rock, there is a clear visual discrepancy. The half strip reaches much further out than the 4th strip. This comparison shows the mathematical inequality based on that physical evidence. Because the 1/2 strip extends further to the right than the 1/4 strip, 1/2 is greater than 1/4. Cutting the whole strip into fewer pieces inherently makes each individual piece larger in size. But this comparison is only mathematically valid and visually trustworthy because Sedge started with 2 holes of the exact same length. Looking back at Sedge's experiments, the glowing matches tell a consistent story. 1/2 equals 2/4, 1/3 equals 2/6, and 1/2 is greater than 1/4. It all comes down to this. Same length means equal. Same hole means you can compare. Sedge taps his remaining strips into a tidy line with his paws and slips off the sun-warmed rock into the current. Before I go, I have a question for you. On same-length strips, would 3/4 be more or less than 1/2? Line them up fair, then judge the size. I'll see you at the next bend.